first one topic I'm going to talk about is business intelligence. I think what we need to do here is try to give you an idea what practical application would be if you can learn some of techniques here about information retrieval and data mining. So business intelligence is one of the very good application you can actually think of. So Toby going to talk about that. And after that, Dr. Kai Xu is going to explain visual analytics. So as I said last time, information retrieval sometimes is also about interface design, how computer can interact with a human. And so Kai Xu is going to talk about visual analytics. How can we using design a novel interface, design a novel visual representation in such a way that the user is able to easily identify, find information they want. Without further ado, let's give the time to Toby. Perhaps I need to briefly introduce Toby. So Toby is CSA, Chief Software Architect in Polecat. So we have a collaboration for the last few years, still collaborating. Toby is you were in the English rugby team. I was quite impressed when I saw his resume and the last bit I showed about the hobby. I was very impressed. And he still can do the programming, at the same time. It was even surprised me. And he did a lot of programming, job in the past, including now the Toby, now the Polecat is a business intelligence. I used to work on the finance, right? So let's give time to Toby to tell us what is business intelligence, how can we use it for research to help us understand that.
Right, good afternoon, everyone. I have this ridiculous title given the size of Polecat, which is quite a small company, and we're fairly new, but we're not quite a startup anymore. Today I'm just going to give you a brief introduction to Polecat, nothing that isn't relevant to what we're going to talk about, and then I'm going to talk about what we try to do, and a lot of this is what we do now, and quite a lot of it is what we'd like to do in the future and what we've got planned, but we already know is difficult, and it obviously overlaps a great deal with some of the stuff you guys are doing. And finally I'm going to talk a little bit about architecting this and how we kind of deal with these huge volumes of data and how we read it all, hopefully intelligently at runtime. So Polecat, the point of Polecat is informing strategic decision makers, and what that really means is we sell our software to really big companies and only a few of them, rather than trying to sell to everybody, and we collect as much as we can from the web, social media, blogs, and we try to present this as a searchable interface to the user high up in these corporations, so that they can they're short of time and they can quickly get an idea of what's being said and make decisions accordingly in a lot of different areas. So some of our customers are there. There's more interesting ones now. This is an old slide. And somebody was asking where Polecat came from, and the two co-founders, who are ex-Microsoft directors, decided on a Polecat because it was small and agile and aggressive. So it gives you an idea of what kind of company we are. One of the things we've looked at is what do our customers really care about, and this is a marketing thing, so it's not that easy to get your head around some of it. But the long and short of it is, imagine these are the different needs of the customers. So imagine a crisis has happened. Shell, a while ago, a load of guys dressed up as polar bears and started going to petrol stations, and they want to know what's going on. They want to know how to respond. They want to know the main things that are coming out of this discussion, how Twitter's reacting, what the national press is saying, And obviously they can't read all this stuff because it's going mad. So one is this kind of crisis management, that's an important one. And the other one, brand marketing, is really, we think about more actually as reputation. So in a long-term strategic sense, can I manage the reputation of my company, understanding what's being said out there about me. There's other slightly more tangential elements to it. Competitor intelligence, what's happening to my competitors, other similar companies. But those two are the main ones we focus on at the moment anyway. So I'm just going to talk about why traditional search fails to do this for our customers at the moment, and then I'll talk about some of the problems and how we try to overcome them. So this is, I've broken this down from the marketing into something that I understand a bit better. So these are the information needs that we think about that our customers have. So one is forming policy, and I'll talk about this in more detail later. But this might be a corporate policy or a governmental policy. Some of our customers are governments. So if I'm going to form policy, I've got to be very informed about what's being said about this and what's most important in a governmental sense to the electorate, definitely. Issue management is the crisis stuff I mentioned earlier. Reputation management we've talked about. And almost the most interesting one, and the least tangible, is briefing. And I love this idea. We've talked a lot in the company about a briefing engine. Can I go and put in a query and understand, can I inform myself in one go? Can I put in the Battle of Hastings and learn everything about the Battle of Hastings in one shot? And we singularly cannot do that, but that's definitely an aim of ours. So here's a kind of key example of where traditional search fails for our customers. So the Irish government was setting the agenda for the Irish Economic Forum, and basically what that is they invite all these people from around the world, particularly Irish people in the diaspora, and you also get people like Bono, obviously, if he turns up to those sort of things. And they discuss the Irish economy and talk about how they can put policy together to improve not only the economy in Ireland, but elsewhere for Irish people in the world. But they didn't know what to put on the agenda. They'd invited all these people, and they had to understand what was being said about Ireland and government and economy. So this is not only a really hard query, it's really hard to understand all the results because there's so much of it, right? So here are two search engines I've gone in and put in something like Ireland and economy, and you can probably guess the blurred out search engines there. And I put that picture up really to sort of highlight how far away from what the user needs these results give. I mean, if I need to understand the whole area, I haven't even necessarily got the right documents here, and obviously there's pages and pages of this stuff. I can't read it all. So that's kind of the problem we're trying to solve in that situation. It's completely different information need to your normal needle in a haystack. I want to find that particular nugget of information, or I need to find this particular website or document. So, as I sort of alluded to, there's a kind of double failure here, if this is the search engine, which is cleverly represented by an engine. So I can't, as the user, I can't express what I want. That's really a difficult problem for me. I want everything to do with Ireland and economy, and Ireland and economy as a query fails me in so many ways. And secondly, I can't really learn from the results what I want. So there's these two parts that basically we try as a company to solve. So I'll talk about the queries first, then we'll talk about the results, and then I'll talk about some of the things that we've done to try and alleviate that. Yeah, and I'm sure you'll talk a fair bit about some of that. We know about software much more than we know about interfaces, so you'll have to forgive some of the interfaces we've developed. So here's another one from the British government we got, and they were interested in the discussion around innovation in the UK economy. This is the Technology Strategy Board, which is part of business and something department. And again, they were interested in forming policy, but also trying to do things and organise events that were really relevant and pertinent to the innovative community, I guess you could say. So again, our query here is a total disaster. because if our query doesn't include the word innovation and UK and economy, we've lost the document. So there's two major problems with that. The first one is a user one, which we need to address basically, which is the user can't put this query together for two reasons. One, if we're thinking about innovation, we've also got to think about all the synonyms that we have for innovation, and it's not necessarily easy for any of us to put together a sensible list of synonyms for these things, particularly whether they're synonyms that are relevant to the meaning of innovation, the semantic meaning of innovation that we've got. And the other one is, Boolean query is fairly intuitive to all of us. So the wider population, we've discovered to our cost, it's a complete mystery. And this is something I've really learned, certainly, in the last few years, is that it's really easy to take for granted how capable the user is. And I'm not suggesting these people are stupid in any way, these are really clever people. But when it comes to some aspects of computing, Boolean query, they don't get it and they're not interested and they want it sorted out for them, basically, which is what happens in a lot of the rest of their life. There's the results failure, so we get pretty low recall from this, and also the ranking tends to really suffer as well. So the whole thing's a bit of a disaster. So there's three solutions that we've started looking at, and some of which we've implemented. So the first one, innovation in whatever it was, innovation in the UK economy. It's much easier for somebody, a user, to look at a document and say, this document describes what I'm interested in. So in some ways, instead of replacing the normal search box, let's allow them to throw a document at the search engine and get results back that kind of are similar to that document or are related to that document. So this can be approached in a number of different ways. So the user can add a document. The simplest way, I guess, is to give a document to the search engine. The search engine extracts what it thinks are the most important terms based on various measures, and then in some instances we can resubmit it to the search engine, get the top results and expand that. So we've got a really kind of good word list, or almost an ontology of terms that describe this whole area. You can go further. Some of the things we've looked at in terms of sort of semantic searching, so trying to understand what concepts are in the document, but of course you're at query time, so you've got to process this stuff pretty fast as well. And again, this gives, in our experience, we get good recall from this, but we get terrible precision. But how we deal with bad precision, I'm going to talk about a bit later on. Okay, so the second one we've looked at is querying by topic, and there was a search engine a while ago called Bleco, I think it's called. I don't know if it's still going, but we shamelessly stole an idea from them, basically, which is that they allowed you to search for topics, and they did it in an entirely different way to us, by the way, so we haven't pinched that. When you put your query into the box, you can put a slash before any word, and that will say, I consider this a topic, rather than just a standard query term. And I guess the simplest way to think, I mean, what in fact they did was they'd pre-indexed all their documents, and they had a list of topics that they already knew about. But we felt this was too rigid, so we wanted to do this at runtime. So, because people could put in anything, right, for their topic, and we're going to have to work out what that topic is and how we search for that. So it's a long story of this, but basically there was some other work done that considered a Wikipedia page as a concept, and so we could think of that as a topic, basically. So the simplest way of thinking about it is somebody puts in their slash query, so they put in McDonald's and then slash obesity, so we're dealing with the obesity topic. We can go to Wikipedia and say, what's the document that best matches the term obesity, and there's different ways to do that, but obviously there's almost certainly a page on Wikipedia called obesity, so that's an easy one for that one. And then again, we treat it a bit like the query by document, and we pull out a vector of the most important terms from that, and then we can start forming a query from that. What was interesting about what we did with this was that we went further, and we then said, well, there's some interesting subtopics around this, so how can we find most interesting subtopics. Now, Wikipedia lends itself pretty well to this because it's got related pages, obviously. But the problem we've got is that there's more related pages than we want to search for subtopics, right? So if somebody puts in business, you've got hundreds and hundreds of related pages. So that then becomes a question of how can we find the subtopics most relevant to the topic, to the kind of super topic. And that was quite a hard problem, actually. And the other thing is that we think of these things as topics, but they're kind of, it's a bit of a broad term, really, and I think to the user they can mean different things. One of the bits of work we did was when they search for a topic, we measure the density of the subtopics that we find. So if they put in obesity, so McDonald's are interested in measuring how much they're being talked about obesity, then we could get a density over the document set for like how dense they were talking about weight or about heart disease or about children's exercise and all these kinds of things. But that's quite different from somebody putting in, as we've seen, something like France. They don't want the subtopic French marching band or camembert, I don't know, whatever it was they had. So we can't treat them all the same, and certainly the more kind of scientifically oriented subtopics worked much better in this situation. But again, it gave us good recall and poor precision. So the third one is not to do with really the query at all. It's taking the searching away from the query box completely and saying, okay, well, maybe we can search, allow users to search in an iterative, exploratory way. Can we find them an interface, basically, that allows them to navigate through the results? And in that situation, we don't want to return documents to the user. We want to return some kind of summarization that they can navigate through. And you know, you put in the classic sort of disambiguation of Jaguar. You put in Jaguar, if you're getting a load of stuff about cars and a load of stuff about cats, you want to be able to drag the cats out and keep the cars and find your way through the results that come. So that also really helps because the user doesn't realise they're doing the work there, but they're reformulating their query all the time as they go. But as I put there, the original query needs to be sufficiently broad, because if it's not, you're only getting narrower. And there may have been work done to broaden that, but I don't know of it, and I don't know how to do that. So that's the problem with the query and how we try and solve it. The next bit is how can we escape these kind of blue links and snippets of documents that don't help the user in this situation. So how can we present the content? So that is results at a glance. What are the elements that best summarize a conversation? And are these elements the same for each content type? By that we mean there's all different types of data on the web, national news, social media, Twitter, communities and forums. It's not necessarily true that we want to see the same information come back from all the same, from different information sources. So, for example, forums and Twitter lend themselves to network analysis, and some of that's really interesting to the user. If you're a big corporation and you want to know who's bad-mouthing you, so if you're Shell and you put in your query about people dressing up as polar bears in petrol stations, you might see quite a dominant Twitter network emerging from that, and that's important information for you, because you can go and kill them or whatever. So we sort of broke down the way we summarise into 3 bits. This is definitely not definitive, and we're working on this all the time. This is some of the stuff we do. Some of it we found to be more useful than others, but we think of it broadly as a kind of simple statistical stuff. So you could do that with a relational database pretty simply. So it's metadata about the document itself, basically, where it's from, who wrote it, what type of content. I mean, a content breakdown is pretty interesting for a user, actually, that social media is going mad and national news is not discussing you at all, or vice versa. The next bit is probably more related to the stuff you guys are doing, is the information extraction stuff. So some of the more prosaic stuff that you'd expect to see, entity extraction and sentiment and topic models and user networks I just mentioned. You can go on and on with that stuff, but in the end we need a third category, primarily because the user always has context, and we're not providing any context by returning those results beyond what their query is. And what I mean by context, or the explicit measures, is if you get a topic model and you put it over a load of documents, that topic model is going to find the n most dominant topics that are in there, but there's no guarantee that that's interesting or important to you. So if you're a large company, so say you're McDonald's, say you're McDonald's, your documents might always be primarily around burgers and I don't know, obesity, say, but there might be particular bits you're interested in, and the more generic aggregating information extraction results tends to give you the sort of top line generic stuff, and that's interesting when you're sort of foraging for information, but it's much less interesting when you have specific needs as a company. So what we've tried to allow them to do is to say, okay, these are the, they might have marketing campaigns that people don't talk about very much, but they need to see how they can improve the uptake of these and where the uptake is. And if we aggregated over all the documents, we wouldn't get a signal from them. So we developed techniques to say, okay, here's my topic. Can I tell how dense it is over these documents specifically for certain customers? Some of those we use some of that query stuff for, so we allow them to do that. And some of it we have analysts who sit there and write big lists of specific stuff, because some of it needs to be incredibly accurate, and to be honest, the topic stuff is not entirely accurate. The other one, reputation measurement, we talked about before, is a really hard thing. It's really intangible, and it's really hard to get right. We're working on that at the moment, and we're still quite a long way from getting that right. But it's an interesting one, and it's one that companies really care about, obviously. It's quite subtle measurements. So, I guess, because it's information retrieval we're talking about here, it's not just information extraction over documents. The document has an importance to the user. It's got its importance is relative to how relevant it is to the query. So we've got a ranking from the search engine, whatever search engine we use, or search technology, and so we know that the first document that comes back, or the probability of the first document coming back, is more important than the last. And in that sense, the information that's extracted from it is more important than the information from the last one. And so this is how we try to deal with this problem of high recall and low precision. What we effectively try and do is degrade the importance of the stuff that we find as we travel down the list to give to the user. The other one is time dependent, so a lot of our stuff is news or social media, so obviously that's temporal data, and the more recent stuff is more important, so somehow we've got to reflect that in presenting our results to the user. So the example of the relevance one is the problem with Barack Obama is everybody talks about Barack Obama, and that's kind of dead uninteresting. If you're saying to people, here are the dominant people in the conversation, and they say it's Barack Obama again, that's not interesting. So there's different ways of dealing with this. One of them, obviously, you could say, how much do I expect to see Barack Obama in the conversation? But another way of dealing with it, in fact, in tangent with that, is just to degrade Barack Obama as you travel down the list. And the simplest way of doing that would just be to every time we find him in a document, we basically weight how we found him by where the document, how relevant the document is to the user. I don't know if that's clear, but yeah, so you can imagine if you wanted to find the most influential people in the conversation, or at least the most talked about, your natural assumption is to say, well, I'll get all the documents and I'll add up all the mentions of all the people, and then the guy who's at the top is going to be the best, most influential person. But of course, that doesn't account for the relevance of the document, so this kind of helps with that. The other one is obviously the temporal stuff, so stuff today is more important than stuff yesterday, and particularly around reputation, when you're measuring reputation, and we've developed a reputation index so people can, or companies can watch their reputation change over time. So obviously stuff that happens in the past has less of an impact today than it did. So the simplest way of doing it is just to degrade the results, but that's something else we've got to think about over time. So the older something is, the less impact it has. So all of these kind of help with that recall and precision problem. The last thing is we've been looking at score distributions. So normally you'd see an exponential decay on score versus frequency. So you get the vast number of the documents that you receive will have a very low score, and that will, the frequency will decrease as the score increases. But work has shown that inside this there's actually two distributions. There's a normal distribution of relevant documents and an exponential distribution of irrelevant documents. So in fact this overall one is a sort of mixture of the two. And one of the problems we've got is we don't, at the moment, we've got such huge volumes of data, you don't want to index everything because you've got to store all that index. So obviously you've got to store the document content itself, but you don't want to start indexing all the information extracted, or the extracted information, because it takes up loads of space, and because if you develop a new algorithm, you've got to re-index everything, and that's a hell of a job. So what we'd really like to do is to read the results at runtime and say, okay, your query's happened, I'm going to go and get people and sentiment and reputation, all these things at runtime. But of course you can't process that quick enough, particularly if you're a smaller company like us and you don't have enormous amounts of hardware. So the question really is, given this decay, can we identify the normal distribution and read enough of it just so that we can process all this stuff at runtime? So even though to the user it looks as though you've processed everything, in fact you've just honed straight in on the most relevant stuff and you're getting a very clear signal, perhaps a clearer signal in the end. So we haven't, that's the thing we're looking at the moment first. So how do we solve both these problems? An exploratory interface, and I say this with deference to the next speaker who's a great deal more experienced and good at this than I am. So this is our product we've got at the moment, which I have no problem in declaring a total car crash from my point of view. So we've got a search panel here that's been shut away, but you imagine the user searched and they get some insights about what's going on, so force and where it's happening in the world, and you can, there's about, I can't remember, 20 of these, and you can mix and match them and make any kind of graph you want. And then you get the documents and you can change that ordering, and there's various things you can do. You can see the data behind this, you can go and create specific dashboards, but I think it basically fails for the sort of user I've been talking about. So we've got analysts who use this, and we sell this to analysts and other companies to inform their senior people. And it works really well for them, and they're kind of data people and they get that. But it really fails for less data and tech savvy people who don't have a lot of time, because they put in their search and they see this, and it's tough for them to, they kind of can't be bothered with it. It's a bit like when I look at my tax return, I'm like, I have to give it to my accountant because I just can't be bothered to deal with it. It's terrible, isn't it? Yeah, anyway, so what we need really there is a sort of holistic view of that that's much more intuitive, so that the user can look at it and straight away they can see, okay, there's the major signals that are coming out of that. Here's the story of the data, and by the way, here's some bits that aren't relevant, or here's a particular bit that is relevant, let's investigate that a bit more. And that really fails to do that, but analysts like it. So we built a prototype of the McDonald's obesity, so the topic searching stuff, and I just thought I'd show that to you because it's being put into the product at the moment, but it's not there yet, so it doesn't come up terribly well. But these are your results, and that's your query that says McDonald's / obesity, and then here are our subtopics, and you can get a sense of the density of the subtopics. And so that's starting to think, okay, you don't need to read any of this stuff here. Here's your hit straight away. If you're interested in a particular thing, you can see it's being out-talked by this subtopic, and I'm worried about this, and my marketing campaign is getting through, those kind of things. You never need to read the document. This one here is simply, is this topic being discussed more or less than I'd expect based on a background statistic. So that's one of the other things we've been working on, and that was an evaluation application, so you can click various things and use it. We gave it internally into some of our customers so they could use it and give feedback. So this is a terrible result, or this looks like rubbish to me, and in fact very few people took the time to do that. So we've got a lot of information. So our first go at a sort of holistic approach is this one, and this is just a guess from us basically, but this is the sort of thing we want to develop. So can this, and we've started an improved, better version of this, and as I say, this was just evaluation. So if The problem is this doesn't run anymore because our data services have changed, and I haven't had time to update it. And the only screenshot I've got is for one bloke who asked to see it, and there was almost nothing about him. You can see there's 5 results. So it doesn't give you a terribly good idea, but you can imagine the colour of the world, the different countries change. You get a distribution for the frequency, topics and publications, and the sentiment of the whole thing. Now, I'm not suggesting this is a good solution, but it's the beginning of what we want to try and do, to try and give you that whole story in one go. So we're trying to do a better one of that, basically, quite a lot better. Okay, and now we enter the arena of the unwell. This is another thing we're doing. So this is about company reputation. So we're working on an FP7, which is an EU project with different universities, and one of the pieces of work is to create a metaphor-based visualization for reputation data, for company reputation. So we thought, a fish tank would be a good idea, right? So imagine this. I'll have to sell it to you. Not a lot of people buy what we're trying to sell here, but so the idea is that company reputation is really quite a complicated thing, and you don't want to trawl through graphs and charts. And what's more, you want to kind of disseminate this amongst your organisation. So the idea would be that you'd have a public space, or many public spaces in companies. So you can imagine in reception, you've got a nice fish tank there, and all the visitors that come in think, what a beautiful fish tank visualization. But in fact, it's telling you the story of the company reputation. So the colour of the water, if it's blue and sunlight's coming through it, then the overall conversation's good. If we've got murky water and it's looking a bit unclean, then okay, things are starting to go bad. The fish here are the influencers, so who are the main people who are talking about me, and the kind of fish they are depend on the sorts of things they're saying. So if people are speaking positively about you, you might end up as Nemo. Otherwise, you might end up as some kind of little shark swimming around. And then the coral represents different topics. So those topics we were laying over the top of stuff. The coral does exactly that. So different bits of coral. One would be government, another might be green energy, another one might be non-governmental organisations. Anything that's pertinent to the company in question. And Johnson & Johnson, I think, have just bought this, so somebody's bought it, so that's good, So you might see that soon, depends how well it goes. But it's a beautiful idea. I mean, I know most people think it's mental, but it's kind of a beautiful idea to be able to convey all that information so quickly. And what's more, when you see it dirty and full of sharks, or some dying bit of coral, rather than a healthy bit of coral, you can click on it and investigate the data and get down to the reason for that happening. And it's kind of I love it anyway. Good.
So is this for a company to use internally or for people?
Oh, well, yes. So
Johnson & Johnson, do they use that internally for their own?
Well, we haven't built it yet, so no, but that would be the idea. Yeah. So basically, I mean, in fact, yeah. So imagine it would be in their lobby, it would be in a big office, it would be on the wall.
External people would see it too.
The external people would see it. I mean, I don't know. I mean, I envisage it like that, but I don't know.
But
why do you think?
I was thinking maybe, so if I'm walking into customers, I don't necessarily want to know that they're not doing well by the water being like that.
Indeed. That's absolutely true, but on the other hand, you wouldn't know that this represents their company reputation.
Oh, yeah, okay.
But I mean, I guess it would just be a fish tank in the lobby, right?
Yes.
A dirty fish tank. Okay, well, think about that. Okay, I'm going to move on now. So just a quick thing to finish off about architecting all this stuff, because obviously we're dealing with enormous volumes here, and trying to get all this meaning out of data at runtime is dead hard. So I'll just give a quick overview, because I'm sure you've covered some of these things. Yeah, how can, of all that stuff, that's what we're holding at the moment, that's 6 months of data, but we do put a year online, so the other 6 months online, a special request when customers pay more. Obviously it costs quite a lot to make all that available in server. So, as I've said, our approach to date has been to index as much extracted information as possible, because storage is cheaper than processing, basically. So we've got, I don't know if you guys have come across Twitter Storm, but it's kind of like, it's almost like a JMS queue, but you get bolts and they hand on bits of work to each other, so you can plug bolts in to do different things. And as data comes in from the internet that we collect, we've got a lot to do to it. I mean, at the simplest level, we've got to work out what language it's in, and it gets increasingly difficult, basically. So we put all these bolts together, and there's some of them there. In order to run this quick enough, because obviously we don't want to duplicate stuff, and we've got so many collectors, they need to we can't have just one pipe running, because we can't do things efficiently enough. But the pipes sort of need to know about each other, because they share information. So we use Gluster. I don't know if you've come across that, but it makes a number of drives look like a single drive, basically. So even though the processing would be different, you can pick documents off what looks like a single drive, and you can share that. Anyway, we found that to be really useful. And the other one that's worth mentioning is Couchbase. And these kind of key value stores we found incredibly useful, to be able to put a load of reference information into one of these and just sit in memory, because we don't get very long for each document, so we've got to work really fast. And those things are absolutely invaluable. You can get a cheap server with a bit of RAM and fill it up with Couchbase key value store. So for example, a load of the models that we have, or in fact for the deduplication, we can keep a 24-hour rolling key value pair of a hash of an article, so that we can easily look it up to tell whether it's a duplicate at any one time. And then Couchbase as well, things will fall out of it. So you put in your key and your value, and you tell it how long it's going to last for. So you don't have to manage and say all the time, okay, that's got old now, throw it away. It will do it all for you. So anyway, I think that's a really good bit of technology we use. And then lastly, obviously distribution is the easiest way to deal with this. We use Solr. I don't know if you guys have come across this, but Lucene is the open source Java search technology, and Solr is a kind of distributed version of that. So we took Solr and we've kind of added a lot to it and hacked it, and we have contributed some back as well, because we like open source. And basically Solr is managed by a thing called Zookeeper, which is kind of like the manager of the whole thing. But the beauty of this is, obviously you've got a master, so your query comes into the master, and the master says, you can imagine each of these are days, say, and then the master says, okay guys, go search, and then aggregates the results and gives them back. But the beauty of this is that each one of these can become a master in a failover. So that's how we're dealing with it. But without that kind of distribution, we're stuffed basically, or you've got a massive bit of tin. I mean, we spoke to Oracle a while ago because we were doing some work for them, and they suggested Exadata as the best solution to this, because obviously we've moved away from relational databases, and we're a small company, so open source distributed technology is excellent for us. But Exadata costs over £1 million, so this costs us the software costs us nothing, so we're in better shape using that. Good, that's everything I have to say.
I have two questions, yeah. One technical and one about your business. Which one would you like to have first? Technical, okay. So basically, I think you answered most of it. I was curious about what's the toughest computations you're dealing with, what kind of languages you use to tackle them, and what experiences did you gather with different approaches to do the computations. I'm thinking specifically about matching a document to a corpus of different documents must be really difficult to compute.
So like the query by document stuff?
Yeah. Or what's the complicated stuff really?
Okay, well in fact the most computationally expensive stuff is, I haven't got it there, but we extract quotations. So the matching stuff isn't too bad, because at the worst you can get a subset of the documents and you're in vector space, and then it's mathematical, it's linear algebra, isn't it? So computers are quite good at that. What's been really difficult is when you're parsing sentences for natural language. So we extract quotations, which sounds dead easy, but is actually surprisingly difficult. So it's easy to find the quotation, but then you've got to find the quota. So I forget, I can't remember the technical name for it, but if you've got he said, or la la la, she said, then you've got to find the reference to that so that you know who's making the quote. And in that situation, you've got a total natural language kind of parsing of it. So you've got to not only part of speech, but you need to break the sentences down into clauses. And we use some, we haven't written all this ourselves, we use OpenNLP, which is really good stuff if you've used it. But if you can try it, if you download the stuff and do that clause parsing, it's incredibly expensive. So that's the biggest challenge we've got. Dependency parsing, exactly. Yeah, and that's kind of the problem we've had with other things, where with sort of entity extraction, we could do our entity extraction more accurately, but we kind of don't have time necessarily to do it the best way, because we've got so many documents coming in, so we have to make trade-offs. In terms of the technology, it's pretty much Java, for two reasons. The most important one being, I'm a Java developer, and I was the first developer in the company. So, but secondly, it's obviously got brilliant libraries, and we save so much money by not having to rewrite the stuff ourselves. So yeah, is that okay?
Yep.
Yeah.
And could I have one more?
Yeah.
So you mentioned you showed the product basically with the screen. So I was curious about so you're dealing with getting a grip on what's going on around in the social media or wherever,
yeah.
and presenting it to some user. And I was curious to know what were the, like, if you could give us 2 examples of things that you weren't able to do before, which companies, which a lot of companies would be willing to pay for. And I'm thinking you weren't able to do before with stuff like Google keywords searches, because they publish also a lot of stuff on what were the latest keywords being used for searches, so you could use that. Obviously they don't present it well, because otherwise people would need this kind of summaries for sentiment analysis. But what's like the things that you were able to sell best to companies?
I'm not certain. In
terms of what do you offer?
What do we offer?
Like what's the question that you weren't able to answer before you came up with the product?
Oh, I see. Well, there's 2 bits to this actually. The first one, well, the original bit of it, one came from company reputation, and companies still can't do this, and this goes some way towards it. But real proper reputation analysis is not there. But the other one was, there's a thing called the sustainability index. So if you did this properly, you could discover how sustainable a company was based on metrics that can't be measured at the moment. It replaces a lot of, we work with a company called GlobeScan quite a lot, and they're out there with surveys doing these questions as well. So you can think about that as well in lots of different ways of trying to answer some of those questions. This is a ridiculously diffuse answer I'm giving you. I haven't focused it at all. I don't know, I'm just kind of making things up. I'm not. But I mean, I can't think of the particular thing. I don't know, some of those things, I guess. It's a terrible answer, I'm sorry. Let me think, I'll talk to you afterwards.
In general, I think it's compared to Google, it's like what you did is record-driven, is it? You show this graph, you show this visualization, it basically should show the statistics of certain topic. Whereas Google or search engine can really focus on position, so that I have to make right for the top returned document. But that really matter what will be the document in the page 2, page 3, and so on and so forth. How can we sample that? Whereas I think Polecat is to try to sort of cover the record, so that from there I get the knowledge, get a better knowledge to help users understand or make decisions.
Exactly what he said.
It's very general. I'm not sure about
how old is Polecat?
Oh, about 4 years now. So it's harder. Yeah.
How many employees do you have, sorry?
Well, about 25 now. So it has been growing. But funnily enough, we started off. There's still quite often when we see customers, there's quite a lot of analyst work going on in here. You can put in, we talked about topics earlier, but word lists and stuff like that. And we're still too heavy on manual use of the product, I guess you could say. Yeah. And so we've slightly grown in the wrong way a bit. We've got too much manual stuff. That's a bad business model compared to, here's my product, use it, I'm never talking to you again. That's better, right? You make more money that way.
I'm just trying to get a sense of how much you can do in real time. What kind of computations can Storm
Oh, Storm?
Yeah.
Oh, blimey. I can't remember what we do. 50 million documents, like proper documents.
I guess you're using clusters.
A day. Yeah, well, effectively, Storm, you can think of it, but we've only got about 3 or 4 pipes on that. I'll have to get back to you on that.
Are these slides there? Will we get a copy of the
Yeah, you're
slides?
welcome to them. I don't know. So I can put them somewhere. I haven't put my email address on it, but Joan has my email address. So yeah, about 50 million documents a day. I mean, it will be these figures divided by 6 months. So whatever that is. I mean, the social media should be a lot larger, but the problem we've got is that things like the Twitter fire hose cost an enormous amount of money. So if you want to collect all of Twitter, and obviously there's Facebook privacy issues and stuff like that. So yeah.
I mean, what kind of conversations are you talking about when you say that many files?
Oh, okay. So, for example, so we'd have all those things.
All done in real time.
Well, all done in indexing time. Yeah. So as they pass through Storm, not this stuff because that's the user overlays that when they query, right? But so these kinds of things. There's other things that are there. I'm trying to remember them now. But yeah, entity extraction, sentiment, topic extraction, key phrases, quotations, those kinds of things. But basically, the advantage you've got is once you've got a document and we've got a part-of-speech tag it anyway, which is quite expensive. Once you've done that, most of the indexing stuff can use that, and also, I mean, things like sentiment or any of the kind of classification. Once you've done your model, that's the hard work done, really. The classification's fast up to it.
If I may, obviously you've done a fair few searches for different people now, and with the reputation measurement for about and the influence search itself, you're going to have to be dealing with lots of different types of influence across various media. Just out of curiosity, really, but have you found many similarities over all those searches and whatnot? Have you found any similarities between influencers across those searches and indeed across the media types which you search? If that made any sense.
So you mean the reverse of that would be that some people are very dominant in national news but never in social media?
Well, no, not necessarily. Sort of the reverse of it sort of being, well, you have one chap who is a powerful influencer in one topic and in a certain medium.
Yeah.
Whereas if you get another chap who is likewise very influential but in a different medium and a different topic, or indeed even on the same medium, are there many similarities between them, or do you find the topic heavily influences the influencers themselves?
Well, it's a very interesting question actually, and it's something that we haven't looked at but we know is important. So, in fact, the way we look at influencers is more around if you get the query really right, and then you're able to look for. You get down to sort of sentence level, so you're looking for some kind of window within the document, and you're not just dealing at document level. You can start to find associations between the entity that's interesting to you, your company, and these people. So that's one way of looking at it, and of course the people who are actually actively writing about you. But it's an interesting question that it might influence what makes an influencer might be different depending on what kind of topic there is, for example. So, and the activity that we might expect to see from somebody who influences an energy conversation would be quite different from somebody who influences a showbiz conversation. I mean, presumably that's what you're talking about. Yeah, the answer is I don't know, but it's an interesting question.
Is that a question about like principal component analysis and things like that? Is that what you're trying to get at?
It might be, if I knew what it was.
But have you done any of that? I mean, I guess.
Not for that, no.
Yeah, that's kind of what you're saying. In a sense? Sorry, I'm tired. I might be talking too quick.
How would you use it for that?
Depends on how you use it, right?
Yeah.
You have a top model over there.
Slightly easier question. Who would you consider your biggest competitor?
Yeah, that's a good question. I should know this better. I mean, there's sort of people like Radian 6 at one end that are competing much more on the social media lower level, media monitoring type thing, and then there's kind of like autonomy, who do some of this stuff over. They do it a lot more internally, though, to be honest, for companies. So enterprise, yeah. So we don't have a lot of people exactly. We position ourselves. I mean, we call it strategic, whatever it is, but that's basically because we're trying to sell to the most senior people in a way. So there's a bit of a niche there, actually. There are definitely people around. I mean, a lot of people like. I guess those two ends is the best answer to that.
Consider McKinsey consulting. Those consultant role, like McKinsey.
Oh, McKinsey, yeah. Oh, yeah, that's true.
As a potential competitor.
Yeah. So that's the software answer, but the kind of company answer is exactly that. These strategic consultants will come in and say stuff. So in fact, McKinsey's have used our software to deliver some of their whatever they deliver. Consultancy, insight.
That was too honest.
So, I mean, that's actually a potential acquirer, really, those sorts of companies. So they're competitors in the sense that they try to offer similar things. But the software is those two ends, really.
So for the people who want to do or still choose the thesis project, so I'm thinking, are you taking some interns this year?
Yes.
Yeah. If you take an intern, what sort of project or kind of program that you have in mind?
I have some. I don't have them with me off the top of my head. If you'd like to work on some of this, we'd be delighted. You have access to all of our data and obviously all the algorithms that are useful to you, although I imagine you'll be writing new ones. Reputation is probably at the forefront of our minds, so we've got good measures or reasonable measures now for overall reputation, but starting to break down reputation into different areas. So it's looking at some of that, and also looking at how conversation changes over time is very important to us. So if you'd be interested in looking at that, so can we watch, can we notice when a conversation has shifted in its language in a sensible way and report on how it's shifted. So you can imagine, I think we did the earthquake one, didn't we, with Japan? Wherever the earthquake was, I think it was Japan. And the conversation started off all about the earthquake and the atrocity and how terrible and the big wave. And then it moved into nuclear because of the nuclear problem, and it moved into economics and how it was affecting the economy. And to be able to watch that through, I mean, we've done some work on it already, some very interesting work, but more of that as well would be very interesting if anyone would like to do that. I would be delighted for you to consume all this data.
Any more questions?
So presumably your users would use this kind of thing to gather the sentiment on the internet about themselves. Did you ever find that causes anger on the internet if people are manipulating this data too obviously?
What do you mean?
Like,
what's being manipulated?
So presumably I use this product and I find that there's negative sentiment about me on the internet, and then I should take action. Isn't that, I should start maybe modifying my online persona somehow.
Yeah.
Modifying what I post, modifying my opinions that I voice, and so on.
Yeah.
Did you ever find that causes outrage, anger?
No, I think it causes the opposite, because for a company, if people are making a right old fuss about something, and the company say, I've heard this, I've listened to you, and I'm modifying my behaviour, that's a great win for the people who are campaigning, I think. Yeah, I don't know, that's the experience we've had anyway. I mean, people get the sense that they're engaging with these monolithic companies and they're sort of having some kind of impact, which is excellent.
Let's have Toby for... Shall we have a 15 minutes break and then come back?